Hello? Okay, cool. Seems to work. So, welcome. In this stream, I'm going to tidy up a function I was working on during the last stream, which is the Haversine distance function for calculating the distance between 2 points on a great sphere. The Earth happens to be one, and I'm calculating the distance between postcodes. So I turn the postcodes into latitude and longitude, and then I calculate the distance between them using this Haversine distance function, which, as I understand it, is basically what everyone seems to use. Yeah, I mean, the Earth actually isn't a great sphere. I think it's like it's a bit squished, but that's what people seem to use. And the distances match tests, basically, that I did. Or not tests, but, you know, I type in what's the distance from this place to this place. And I got the same distance, so whatever. Yeah. Now. What I've got is, I'll just show you. Okay. What I've got is this function left over. So I wrote a function using numpy because I tried using this library here, geopy, to calculate the distance. And it might be possible to do this in a vectorized fashion. But I couldn't find a way of doing it in a vectorized fashion. Using geopy. Yeah, so I couldn't find a way of doing it in a vectorized fashion using this geopy.distance thing. So I decided instead just to figure out what was the equation that they were using. And this is what led me to this Haversine vectorized. And I used a little bit of ChatGPT to give me a hand. And basically produced this function, although this isn't really a ChatGPT function at this point because I did so much work on it. So what this can do is, compared to this function, so I've got get distance by postcode, and if you run the two, let's see, yeah, so if I run this, p run s cumulative, so this is basically profiling my script, profiling this cell, and it will tell me how long it takes to calculate the distance between this particular postcode that I've chosen and every postcode that I have in my data set. And just to track back in case you don't know, the whole point of this live stream series is to build a housing data set, a synthetic housing data set, and then build a recommender on top of that housing data set, so that if you said, oh, I live here, I want this many bedrooms, I want this kind of kitchen, etc., you would get a recommendation or rankings of those houses, and you would see the top 5, top 10, something like Rightmove if you're in the UK, and that might be in America too. And the point is, I'm working on recommender systems in my like personal work, in my like private work or whatever, which I can't really talk about. So this is just a way for me to talk about it, and learn and hopefully teach things that I've learned. So yeah, so I've built the data set, and now I'm just in the point where I'm doing feature extraction, so that then I can feed that information into the recommender. And this is the first thing I'm working on, which is postcodes. And what I've got is a data set, an open postcode data set from the UK government, I'm reading it in, I'm assigning values to all of the columns because that doesn't happen already. And then I'm extracting just the postcode with no space, the latitude, the longitude, and using that to, I guess, read in to, oh, hang on. I just realized I don't actually have any of this stuff loaded, do I? Probably. Just hit run all. So anyway, yeah, whilst this is all running, yeah, so I'm reading in that data set, and this is the data set that I use, the postcode data set, for, say, a user comes in and says, I have this postcode. I can directly look up what postcode that is by indexing into the postcode data set using their postcode with no spaces in between. And obviously this, yeah, I mean, postcode no space is okay, but we could go even further and just say like lowercase everything or something, because you don't actually know when someone types in a postcode that they're going to do it all in uppercase or whatever. And then you have this thing where it's like, oh, your postcode wasn't found, and that's not a very good user experience, but we're not at that point right now. Okay, so yeah, you can see here, I may as well talk it through. I've got the house data set that I built here, which is red in at the top. And you can, incidentally, you can find it if you want. I think I've linked it below. It's on my Kaggle. And I've replaced or changed the house data latitude to a float type and the longitude to a float type. And look, you can see it's gone through it now. Nice. Okay, cool. So I might just, will this run? It won't run. That's fine. Let's just comment it out and get it out of the way. This one run. Yep. So you can see, you know, that was just one calculation, and that wasn't super fast. Well, it was fast the second time. But now this is in my data set. The data set was 30,000 rows long. I had to remove some because there's some still some dirty data, even though I created the data set myself. So that's just accidental. So I had to remove some. So it's about 29,700 rows, 29,727. Let's see if I was right. See if I could still remember that. Oh, so close. 57. Okay, 30 off. Yeah, so if we run this, you'll be able to see that this profiles the code and tells us basically what's slowing it down, how fast it is, how long it takes, etc. Sorry if that makes a noise. Cool. So cumulative time, built-in methods, blah, 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 whatever. I've been inside of this thing, this one call thing. I guess this is the cell, I'm not sure. But it took 26 seconds, basically, roughly. Now, if we look up here instead, what I can do is I can extract coordinates from house data. Say those are coords 2. And then I can run on coords 1. This is just LA. So it's just the coordinates of somewhere in LA. And the Haversine, sorry, the coords 2 are all the house data coordinates that I have in my data set. I've got this Haversine vectorized function. So I'm going to feed in the coords 1 and the coords 2. Then numpy arrays of latitude and longitude coordinates. I will reshape coords 1. Well, I'll reshape either of them if they're 1D, make them 2D, so that this algorithm is basically, you don't have to treat them specially. It's just you make it all the same format so that you don't have to treat them specially. And then if coords 1, so I'm only doing this for coords 1. If coords 1 is just a single pair of latitude and longitude coordinates, I tile it down so I have the same coordinates repeated, so that I can calculate the distance from just that coordinate set with all the other coordinates. Okay. Yeah. So mp.radians, blah 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 blah, r equals. This is the Haversine formula. I have to put everything in radians because numpy works in radians. And the radius of the Earth in kilometers is 6,371 kilometers. I'll probably change this to miles. As you can see, it's got that for miles. This was ChatGPT that did this, so not bad. And then I return this value, and this is the distance, basically. The distance between the coordinates I give, which could be either the same length coords 1 and coords 2, so you could do multiple different location to location distances, or one location to many locations. So let's see how long this takes. If I just do a p run, actually I'll tell you what, I'll run it first because it was very fast anyway. So let's see how long it takes. P run -s cumulative. Okay, so for the same calculation, did it in 0.005 seconds, which is, what's that? This would be a tenth, a hundredth, a thousandth, so 5 milliseconds. Significantly faster than 26. I mean, what is that? That's already like a factor of 1,000. So yeah, it's like 5,000 times faster. So yeah, is it? Wait, 1, 2, 3. Yeah, 5,000 times faster. So now I need to turn this into a nicer function. So I want the choice. I'm going to say bool equals true. And the point of this yeah, so the point of this is to decide whether I want to use miles or kilometers. And I'm going to say that by default, I'm going to use miles, because that just happens to be the standard unit of distance in the UK, not kilometers. So use their full name, address them by their full name. Okay, cool. So I'll tell you what, let's use the Python equivalent of a ternary. So this is a really nice thing if you haven't seen this before. What you can do is you can say some value equals something if something else this value. So I'm basically saying it's sort of r is equal to 3,956 if miles is true, else r is equal to 6,371. And because miles is a boolean, I can just chuck it straight in there. Okay, cool. distances I get now. Nice. So this is cool. What I want to do now is, well, I guess I partially want to check it. So one of the things you can do, even though it could take a while, is you can check if a function that you've created is performing correctly by using something called the golden model method. So the idea is that this is the model I've created for measuring distance, but there is a golden model. There's a model that always produces the right answer. And in this case, the model that always produces the right answer is basically this one. HowsData.apply this, the distances. So if I say distances geopart is equal to that, and I'll let that calculate for the incredibly long amount of time, and instead I will get this user postcode. I just need to know what the latitude and longitude of this are. Maybe I should tell you what, let's do this. Let's do that first. Is that it? Maybe I'll get rid of that as well. We already know the time. Okay. So if I say now then, if I put this here, get this. What? So annoying having lots of long output. So yeah, so I've just got the coordinates of this by using this get distance by postcode function, and now I'm going to put it in here. Okay, it's no longer LA, and I'm going to get the distances. Then I want to see for index in range length. So what I'm doing here is I want to check using the GeoPy golden model that the distances I'm producing are the actual distances. And so the first one is quite badly wrong. Oh, okay, and it's because one's in kilometers and one's in miles. So if I say cohorts 1, cohorts 2 miles equals false, and I do that again, what do I get? Okay, so we get a minor error, basically. So let's round to the nearest kilometre. Oh, that's still going to be wrong, isn't it? Let's floor, because that suits me slightly better. Name floor. Ah. P.floor. Maybe instead then. Let's do distances geopy index minus distances index. Sorry, 1 second. Oops. Okay. It's less than 3. Damn. Kiera 74. I'm going to turn this into a try statement now, because basically it should work. Basically, I don't want to print out the index every time, because this can take a long time. If you print out things to the output every single time, it can really slow down your cell or your function or anything. So it's better just not to have IO. So what I'm doing here is just saying, okay, do this, assert that that is the case. If it's not, then you can tell me why it's not. Oh, there we go. So you can see it's actually much faster without printing it out. Yeah. So that's that then. It works to within 3 kilometers. Our golden model has proven how long, has shown how long it can take. So I guess what we want to say now is get distance by postcode. So we don't want this anymore. Coordinates. Okay. So what I'm going to do now instead is I'm going to have 2 functions. One of them is the Haversine vectorized, which does all the calculations, distance calculations in a vectorized manner very fast. Then I'm going to just get rid of this and get rid of this, get rid of this. Don't want to leave this in. It's kind of cool to show how you would check something like this with a golden model. Yeah, I'll leave it in. Slightly confused by what it's saying this average view duration is. Because I clicked on it or something. Anyway. Yeah, get rid of that. Okay. God, that's slow. I think this is where I got the so what I'm doing right now is just getting the postcode coordinates from elsewhere rather than doing it myself again. And I think this uses the same data set that I used, and I just clicked convert and it took forever. So yeah, rubbish code everywhere. That's a bit messy. So just tidy that up a bit. That's nicer. Okay. Cool. Obviously this is going to take a long time because this takes a long time, but basically the idea behind this is simply because I've created this function. Yeah, you see it worked. Who knows if it's right, who knows if it's wrong, whatever. In fact, actually, I might just see if you get to the bottom. And that would just, I guess that would probably say, oh, maybe it won't. Oh, okay, actually. Run it again. So basically, inside of this notebook, I just want to include proof to myself and to anyone who reads it that the Haversine function that I created is accurate. Okay, cool. Cool, so I can delete this as well. And I'm left with this function, which returns the distances for me. So I'm going to change this get distance by postcode function now. That might just be exactly a rewrite of what I had before, but okay. By the way, these are type definitions. And if you don't do this already in your code, you should do, because it makes it so much easier to understand what the inputs and outputs are, because it just adds that extra bit of information. Some languages, I can't think of one off the top of my head now, I guess maybe Java, things like that, C, force you to define types. Does C force you? C actually might not force you, but lots of other things force you. And the reason is, well, it's faster to compile sometimes, it makes your code faster, but as a user it adds an extra layer of information. As like a consumer of the code, it makes it a lot easier to understand what's going in and what's going out. So you should use them. I might tidy this up later with ChatGPT. I'll just add here as well. Okay, cool. So let's shorten this a bit, because it's a bit overly long. What I've done here is, in fact, I might just make this a bit clearer, as this is a proper piece of code now. Space equals that. Okay. Don't need to print those. Return. Maybe I don't need to say that as well, in fairness. Maybe just that. And then I could say return Haversine vectorized coordinates. I've already got coordinates. So let's call this one postcode coordinates, the other one just coordinates, and this one miles equals miles. And as it's a bit overly long, let's just put it down here. And so, now we've got a nice function, well documented, etc., that relies on this Haversine vectorized function to quickly calculate the distance from a postcode to a set of coordinates. Okay. And so this is the first bit of feature extraction. So I can use this now. So let's build the postcode distance function. Let's add some markdown and explain. Cool. So the way this works is something like this would then become part of, so the get distance by postcode function would become part of a feature extraction script that gets called. So I've got the housing data set, I've got my input data from the user, and as part of the feature extraction script, I'm going to call get distance by postcode, and it's basically going to run stuff, and it's basically going to run on the data set and produce the output. So I guess what I can do is I can just show what that would look like. What should you call this? Yeah, so basically this script is going to run the feature extraction modules on the house data set using the user provided values input. So def extract features, and we're going to say house data be data frame. Obviously this is going to have, and then I don't know, user vector or something, and let's just say it's a dict for now. I should call this rank houses actually. No. Yeah, so what I was just thinking there was maybe it should be ranked, but actually extract features makes more sense because you're going to have a house data set, you're going to have a user vector. You can input those things into the rank houses function. So there's going to be a function above extract features. And the first thing that function will do is extract the features that it then uses to rank the houses. So I think it makes sense to separate it this way. It's much nicer. You don't want to have a monolithic script that's got everything that you're doing in it because it makes it very hard to manage. So yeah, I'll probably just use ChatGPT to do this. So the first thing I'm going to do is say, first thing I'm going to do is say this. So I'm going to create a new data frame and I'm going to say the first feature is called distances or distance is equal to get and then let's just pretend that the user vector contains something like postcode. Say miles equals true because we do it automatically. Okay, cool. Yeah, that works. And so if I run what postcode was I using before? So we can just see if this works. Pd.dataframe. Okay. Do I need to get top values? Oh, it doesn't like it. That's interesting. That's fine. Hey, there we go. Cool. So that's the distance in miles. Nice. That's nice. Okay. So that's that then. That's this part complete. And how you sort of go from a normal, basically a function that you've sort of thrown together and turn it into a much nicer, more complete, more like easy to read and understand function. Let's just see. I'll show you one more thing, perhaps. So this is something I like to do on ChatGPT. Okay, see what this does. Cool. Didn't actually have anything here. House information using the provided user vector currently completes distance of each house from a special. Don't need that. Parameters expected to have columns for latitude, data frame containing. Yeah, sure. Features currently includes a column list. Data frame. So you can see it actually does like a really good job of stuff like this. ChatGPT, it does a very good job of explaining what your code's doing, and it's one of those things where I don't typically trust ChatGPT to write like proper code that I'm going to use in production for me. If you watch the previous live stream, I did use it to produce the Haversine function, but that's because I didn't actually know how to do that, and sometimes seeing something in code is a lot easier. But once it has shown me how to do it, I then updated it and changed it to function in the way that I wanted it to, with the comments that I felt were necessary, etc. But when it comes to doc strings, it's actually quite good at reasoning about what you've already got down, and it can look at it and understand what you're trying to do. And it can write very good doc strings for you. Like, you might be able to write a better one yourself, but it'll take you a long time, and ChatGPT can do it effectively instantly. So you may as well use it. And sometimes it tells you like, oh, your function is doing this and this and this, and you're like, is it? As in, it will pick up on something that you might have missed. So it's very useful. Okay, so that's the first thing done. I've put it all into the extract features, and the next thing I'm going to be working on, so if we just look at the data set, is house type, and then price, and then bedrooms, bathrooms, etc, etc. Yeah. Catch you in a bit. Bye.